Okay, so now we're recording, right? You see the little pause button and all level. So I have some kind of nice broke down notes for some of the stuff we do that I will give you. So if you ever need extra help on anything, don't hesitate to ask, because I probably have resources that I have created over the years. So let's talk about quadratics. What is a quadratic? Don't be scared. Don't be shy. You would think it's something with 4, but it's not 4. What is it actually? Give it to me in terms of an equation, and then we'll talk about the graph. What's a quadratic equation look like? What's special about it? It's got the x squared in it. You're exactly right. Yeah. Parabola. I like to say it wrong, but yeah, that's okay. We're looking for this exponent of 2, power of 2, right? The equation looks this way: ax squared plus bx plus c, but you don't see the a, the b, and the c there. Those are called what? Starts with a c, a number in front of a variable. Constant doesn't have a variable. If it's hooked to a variable and it's a number in front, what's it called? My goodness. This whole thing is a term. The terms make up the entire expression. The x's are the variables in there, and in this case, the a, the b, and the c, for instance, if I had 5x squared plus 2x minus 5, these are what we call, y'all know this, you're just blanking. They're called coefficients. Coefficients are numbers that are hooked to a variable. They can have exponents there as well, or maybe not. But it's just the number in front of the variable. Everybody okay? Sure? Okay. When we graph these, Miguel, what'd you say they're called? No, when we graph them. A parabola. That's exactly right. So the parabola can be many different shapes. It can face different ways, and we're going to talk about some things that causes this parabola to flip upside down or right side up. But before we do, let's talk about some key characters. Do y'all remember this from Algebra 1, by the way? Okay. Some of us not. If I talk too fast because I get excited, tell me to slow down and take a breath, and I will. All right, let's talk about some key features of a parabola. Tell me something you know. Anything you know about a parabola? It's curved. Okay, good job. It's what? They're on graphs. Okay. Continuous. They do have that exponent, biggest exponent being 2 on the variable. They are symmetrical, and I'm going to stop right there for just a minute. They are symmetrical, so they have imaginary little line. I'm not an artist, and I'm sorry in advance. Nothing will be drawn from scale. If they are symmetrical, then that means they have this line that divides them, which means they're the same on either side, right? That's very, very, very important. Does anybody know what we call that line? A line of symmetry, right? When we start talking about quadratics, we're going to call it an axis of symmetry. And there's a reason for that we'll get to a little later. Axis of symmetry. So here or here. What else? What else do you know about a quadratic? About a parabola, rather? There are numbers. It could have more than one x-intercept. You're exactly right. That's a great point. We call those x-intercepts, by the way, when we're talking in terms of a parabola, we will often call them roots or zeros. Why might we call them zeros? What's 0 on an x-intercept? The what? The y. So if I'm looking at an x-intercept, the y is always 0. If I'm looking at a y-intercept, then the x is always 0. What else? What? Vertex. That's exactly what I want you to get to. Vertex. This is different than a line that goes off in both directions, because in this case, this has a very highest point or a very lowest point, depending on which way my parabola is opening. So I call this an absolute maximum or an absolute minimum, depending on where, because it's absolutely the lowest or highest point that will go, but specifically we call this the vertex. And the vertex is a very, very, very important part of the parabola because it tells us lots of information. Yeah. Everybody okay? Yeah. What a parabola what now? Okay, let's think. You ever have a soft rocket when you were a kid? Yeah. Come out, stop it, and fly it. This one's a parabola. That would be a parabola. Lots and lots of, and in fact, if Ms. Hutto and I can get together and create the project we're talking about now, we're talking about possibly having y'all create one of those. We have a little competition between the two classes if we can create the best highest soft rocket that goes or the one that has the most spread to it. We'll talk about it. You've never seen a soft rocket? The little rocket hooks to, got like a pump. Yeah, you stop it and it pushes air up. You what? Well, okay, that's against the rules. All right, everybody okay so far? Basic stuff, we haven't done any calculations. We're just looking at what happens here. All right, let me make sure I tell you everything I want to tell you before we... Let's talk about some things that impact our graph. Let's go back to that, what I gave you to start with, and I'm actually going to rename this f of x. What does f of x mean? Function of x. What does it mean? We talked about this just a little bit yesterday. What does it mean to be a function?
Please pardon the interruption. Students with the last names starting with B through Z, please report to the library.
B? She said B?
Kept your device
Or
over the
P,
summer,
maybe.
please stay put. That's B through Z. Thank you.
Did she just do? Oh, B. Okay. I don't know. All right, so being a function means it maintains one and only one output for every input. It passes that vertical line test we talked about yesterday. Does everybody remember that? It can't have more than one. Every x can only have one y that goes with it. It can't have multiple y's. So these are definitely functions, right? There's no place I could place a vertical line where it would ever possibly touch more than one time. So I'm going to call it f of x. And I'm going to do, this is what we call bless you standard form. Yeah, you got to say it like that. This is bless you standard form. Somebody did. All right, what form is this? Bless you standard form, thank you. This is bless you standard form. Okay, so it's in standard form for a couple of reasons. The exponents are in descending order, which means I start with the biggest and I work my way down. And you might say, but Miss McGee, I don't see an exponent on this x. But really, there is one. What is it? There's an implied one there. All right, A, B, and C, we have already talked about our coefficients. And I'm just going to say actually A and B are coefficients because actually C is what? A constant. There you go. Let's look back just quickly. This 5x squared plus 2x minus 5. What is A there? What's A? 5, the coefficient. It's actually called the leading coefficient because when it's in standard form with the highest exponent, it leads the equation in front. But that is 5. Don't tell me it's 5x squared because it's not. When I refer to A, I'm only referring to the coefficient there. What is B? And what is C? Negative 5. Be very careful because the sign follows with it. Everybody good? Am I going too fast? Sure? All right, you got to speak up if I am because I'll just keep on going. And we got the constant there. Somebody tell me what that constant, do you have any idea what that constant might do to the equation or to the parabola? It's the Y-intercept. Moves it up or down. It absolutely does. Did y'all already talk about transformations of graphs? That is awesome. We're going to hold a unit on that. will transform some pretty. That's okay. That's okay. I'll just. I'm pretty impressed though because that's the first time I've had that with this class. They told me they knew that that was the transformation. So that's good. That's good. That's a good thing. Okay. Somebody else said that's the Y-intercept. Based on what I told you about intercepts before, how do you know that's the Y-intercept? How do you find a Y-intercept algebraically? Set the x's to 0, right? If this is 0, this is 0, what's that leave? So the Y-intercept there is -5. So my C is very beneficial in information given because I'm going to be graphing these. It is also my, whoa, Stacy, Y-intercept. The other value that gives us tons of information is the A that is in front. And so I'm going to come off to the side, and I'm going to talk about this A for just a minute because it does a lot of things. The first thing it does, and if you're good with your function transformations, you will know this. We're not going to factor yet, but we will get to factoring. Is it a factor? It could be. Maybe, maybe not. We won't be factoring it out. All right, if A is greater than 0, that means A is what? Positive. If A is positive, that means my parabola, my quadratic is happy. It's going to open up. Okay? That's a normal standard parabola. However, if it's negative, what does that mean in function transformation terms? If you've got a negative out front, if you negate the front of the equation, you don't remember what happens then? It flips. It's a reflection. It's a reflection, so it flips upside down. So if A is, if you don't know that or remember that, that is okay, I promise. All I want you to know right now is that if A is negative, that means my parabola is going to open down. Standard form is the hardest to graph in because it's not as easy to just apply transformations to, but it is also the most common to see to be asked to graph in, so that's why we spend so much time learning to graph in standard form. All right, positive, negative. Now let's talk about the actual value of A. Yesterday when we were playing that little Kahoot, you saw these symbols. What does that mean? The absolute value, okay? As the absolute value of A gets smaller. Now, if I'm talking about it getting smaller, but it's an absolute value, what do I mean there? Okay, so let me tell you this. Let's say that A equals 1 is your standard normal, that's your parent graph. Now that's a normal width. What do I mean if the absolute value of A gets smaller than 1? How can it be smaller than 1 but stay positive? Is what I'm getting. Decimals. We're talking about decimals and fractions, but be careful about the fractions because fractions can still be over 1, right? So here I'm talking about decimals and fractions, but as A gets smaller and smaller, what do you think happens to the graph? It gets bigger. It does the opposite. You're exactly right. It is a horizontal stretch there or a vertical shrink, however you want to think about that. But this does make my graph get wider. So it does the opposite of what you'd think it does. And then, of course, as the absolute value of A gets bigger, my graph, what do you think it does? That's right. It gets skinny. Is there smoke coming out of your ears yet? Are you okay? Y'all good? Y'all not laughing with me or anything. Let me give you an example. And then we'll get to the graphic part. You need me to go back? Oh, if you just click on my picture when you're in Canvas, it should take you right to where I'm writing. I think that's the way it works. The little icon at the top. Do you see my picture up there at the top? Huh? Uh, let's say I have negative. We'll start easy. What do you know? Tell me what you know. Tell me something you know about the graph without actually graphing. Okay, so I'm looking at an upside down parabola, right? A very sad parabola. So I'm opening down. What else? Yeah. Y-intercept is 5. Y'all don't have to raise your hand if you don't want to. You can just. Wide. Why is it wide? I got that fraction, that 1/2, and that's definitely less than 1. That's a lot of information to get to not have done any type of calculation, right? What's your value for A there? Negative 1/2. What's B? Oh, it's 0. Good job. It's 0 because it's not there. What is C? 5. Good. Tell me what you know. I tried to throw you. Look up there. It's a skinnier graph than the parent graph. Remember, we're always comparing to 1. 1 is an average standard parent graph. So because this is 4/3 is actually bigger than 1, even though it is a fraction, it's going to get skinnier. All right, somebody else said something else. There is, so what would the B value be? Negative 1. There's no, it looks as if there's no coefficient there, but really we know that when there's no coefficient there, it's still there, just 1. And the negative is going to stay with it. What else do you know? Okay, I have a y-intercept of 6, absolutely. Anything else? X, right? Are we all okay? All good. Okay, I'm going to give you just a second because whenever we get into the graphing, it's going to be long and monotonous, and I'm going to apologize ahead of time. So take 2, breathe for a second, digest all that, and then we'll come together. If you are referencing the sheet that I just gave you, there are some steps there to graphing that you can follow. There are also the little helpful hints that we just went over about things that the coefficients do. They're broke down in a little bit, not quite as sophisticated terms as we talked about, but in terms of the happy and sad and everything else. Remember, I've taught all levels, so this is kind of a broke down version of how to graph. All right, let's talk about what we're going to do. I like steps, and so if I ever get the opportunity, you will see me list out in steps, so that if you ever go back to your notes and you need to reference how exactly do I do this, you will have it there. I'll put the steps here, and what I'll do is I'll run an example on this side to follow along with the steps so that you will see what is going on. Let's do before we graph and before we get into all this, and while y'all are copying this down, tell me what you know before I graph. Skinny or wide? Wide. Less than 1. Up or down? Down. Y-intercept? -1. See how quick that was? And you'll start to get it, and you'll see them, and you'll just go boom, boom, boom. Okay? I know a lot about it before I even start. That's a good thing. Very first thing I want to do, we talked about two important aspects of that parabola. We said one were the x-intercepts, which are also called the roots or the zeros. We also said the other important part was the what? Starts with a V, the vertex. So the first thing we're going to do is we're going to find the vertex. By finding the vertex, we are also finding the what? What goes through the vertex? What's it called? What kind of axis? Axis of symmetry. Good job. Axis of symmetry, I think it's referred to as a line of symmetry on your step sheet there. But either one. So the first thing we're going to do is we're going to find the vertex. To find the vertex, I am first going to find the axis of symmetry. Because this is a vertical line, it's in the form x equals, right? X equals a number is a vertical line. Y equals a number is a horizontal line. Do we all know that? Okay. All right, so I'm going to say here the axis of symmetry, which is also the x-coordinate of the vertex, and I'm going to give you a little formula. Opposite B. Now, I put negative B and I said opposite B. And I did that intentionally because what if it starts out negative? It becomes positive, right? This doesn't mean B is always negative. This means you do the opposite of the sign that's already there. So opposite B over 2A is going to give me my axis of symmetry. Hardest part about graphing in standard form is remembering how to find the axis of symmetry, plugging in and doing it correctly. So if I go over to my example on the right-hand side, what is, I guess I should have asked you before, what is A in our equation given? Negative 1/2. What is B and C? Negative 1. So what is opposite B? Negative 2 over, now I have to do 2 times A. So I've got 2 times, what is A again? Negative 1/2. If you start struggling with this, do not be ashamed. If you need to come here and go, okay, let me do A equals negative 1/2, B equals 2, and C equals negative 1. That is quite all right. All right, it'll help you keep everything straight if that helps you as you go through. All right, so now I need to simplify, and I need to remember my order of operations, and because 2 times 1/2 is together there on the bottom, that's grouped there, so what's 2 times 1/2? 1, so this is really negative 2 over negative 1, which is 2. I'm going to go ahead on my graph, and I'll come back over here to this. Don't freak out on me if you're still there. 1, 2. I'm just going to dash in my axis of symmetry. You do not have to draw the axis of symmetry on your graph, but it will help you as we go to locate the vertex. And to know that that is my line of symmetry that is going to divide my parabola into. Same on either side. Everybody caught up with me, or y'all need me to wait just another second? Y'all got to talk to me now, my goodness. Y'all ready to move on, or you need me to wait a second? Okay, thank you, thank you. Of a coordinate, because I know my vertex is an XY coordinate, right? And a coordinate, it's got that X part and that Y part. How do you find the Y part if you have the X part? I have an equation. This equation literally says, remember f of x and y are the same thing. It literally says y equals all of this, and I can plug in any value for x, and I can find the y that goes with it, right? So if I want to know where on this line my vertex sits, I'm going to check that x value, and I'm going to plug it into my equation. Plug in to find y. I guess I should list your steps. This is step 1 on the vertex. So here, what I'm really doing, just like that Kahoot yesterday where it said, what is f of this number? I'm finding f of 2. I'm plugging 2 in for x in order to find the y value. So if I plug 2 in here, I get negative 1/2, 2 squared. So be very careful. We talked about a lot yesterday in just playing a Kahoot, didn't we? When I've got this negative 1/2 times 2 squared, the exponent trumps the multiplication every time. So 2 times 2, because 2 squared first, right, is 4, and then I multiply by negative 1/2. So what do you get? Negative 2. That's right. Plus 4 minus 1. Now left to right. Is that confusing, anybody? Okay. Yeah. That's what everybody keeps asking. So there's another chair here with a cord. That's the one. There's an outlet there, and you can unplug it, but then you have to move. Not near you. This old building has virtually no power. Okay. So what's the y coordinate of the vertex? So what is the vertex? What is the coordinate, or what are the coordinates of the vertex? 2, 1. My vertex is 2, 1. Are we all in agreement? Are we all okay with how we found it? 2, 1. Sometimes I'll put a little V there just to let myself know that is my vertex, because I'm going to be fine, especially if I didn't draw the axis of symmetry through there, which you do not have to. All okay with the vertex? All right. I need a total of 3 points. Some teachers will make you find a whole lot more. I think 3 is sufficient. I need 3 points in order to graph a parabola. One of them must be the vertex, and then the other 2 must be on either side of the vertex. That way I can kind of get the shape of the vertex, the shape of the parabola going. So the next part is the kind of whatever floats your boat kind of part, because it doesn't really matter which point you use for this next one, just so long, because I've got to have one on either side, right? So I call this finding an easy point. Now, oh, it's really close to the last one. The easy point could be different for each one of you. If I'm looking at this problem, I'm going, I already know another point on that parabola. What is it? Look back at your equation. The y-intercept, right? That's in there. Why not use it? That's pretty easy to me. Do you agree? The only time that won't work is if, and we'll put a note. I'm going to put use y-intercept if you can. When could you maybe not use the y-intercept as another point? When the vertex and the y-intercept is the same thing. Then you can't use that as your easy point, right? Or maybe on the end of my equation I have plus 475. No way I'm going up to 475. So that's another time maybe I don't use it. But if you can use it, most definitely use it. In this case, I can. And it's -1, and I can just put the point there at -1. So here the y-intercept is -1. Now, if I had not been able to use that, I need to pick an x value, and I want to stay close to my vertex, because remember what that parabola does? The further away from the vertex
you get. Pardon this interruption. This time, our senior class report to the auditorium for our class meeting. This is our senior class. Thank you.
The further away from the vertex that I get, if this is at x equals 1, then if I picked x equals 10, look how high up I'm going to have to go to get there, right? So I want to stick close to the vertex. So if I was doing this problem, and we'll do one where the vertex is not a good problem, I mean the Intercept's not a good problem to use. But if I was doing this and needed an easy point, I would choose x equals 1 or x equals 3 because those fit right close. Does that make sense to you? And then you would find the corresponding y value by doing what? If you have x and you need y, what do? Plug it in, plug it in. Y'all remember that commercial? Okay. We use that though. We'll do one where we don't use it, but for the sake of the example here to keep this short and sweet, which I know it's not, and I'm sorry. Let's do the last step. I'm going to guess that you could figure out the last step on your very own without me telling you. I have the vertex, which sits on the axis of symmetry. I have a point on the other side. I don't even need to do any arithmetic here to figure out the other point. What do you think I do? Just flip it. Just reflect it over. I call this last step, and it's my favorite step. Reflect and connect. Use those geometry skills that Ms. Byers taught you last year. Reflect that point over that line of reflection there in the middle. These are easy reflections. You literally just count to the reflection, the line of reflection, and continue counting that many. So, 1, 2, 1, 2. I reflected, and now I am going to connect. How much you remember from Algebra 1? What is the domain? Okay, what is it? What x values can be on my parabola? I think we're going to end up having to take a day or two talking about it. So how do I say that? All real numbers, x can be all real numbers. Clearly, I can tell by the look on y'all's face. We'll take a day doing the range. We might just know what the range is here. What values can y be here? Anything under 1. Or, yep, you're exactly right. Anything under 1, including 1 because the vertex is on 1. We will definitely, because I'm going to teach you a new notation to write that in. Okay, so far, and I know that's just one example, and I'm going to do another one. Give me a thumb. I got it good. I can do it. It's okay, or I don't got it at all. Everybody give me a thumb. Okay, all right, let's do one more example. You're freaking cold. Well, you might have to freaking move somewhere else because it's a cold spot. I don't care. I mean, if somebody, do you at least remember quadratics? That's okay. Listen, my philosophy is because I algebra 1, you should be able to do anything and everything with a linear equation. After algebra 1, okay? Whatever I ask you with a linear, you should be able to do it. When you get out of algebra 2, huh? A linear.
Why do we have geometry before algebra?
We used to do it. We switched it for a while, but with your tests and your like standardized tests that you have to take, there's a lot of geometry concepts on there, and you'll be taking like your PSAT and things like that. If you haven't had geometry, our test scores are just in the bucket on that, so they throw it in the middle of it. Whatever. I don't know what standardized tests. Well, 5. Good job, Sully. What is B? 0. C. Y-intercept. Up or down? Skinny, wide, or average? Oh, good job. Okay, let's graph it. First, I need to find the. Okay, how do I find the axis of symmetry? Opposite B over 2A, yes? So it's 0. Can I have a 0 in a fraction like that? Oh, can I? I don't know. I'm asking you.
Yeah, but it's a 0.
I can have a 0 in the numerator. I can't have a 0 in the denominator. 0 in the denominator makes it undefined, but a 0 in the numerator, which is the top, means it's just 0. So the axis of symmetry here is at 0, which means what? It's on the y-axis. There's my axis of symmetry. Are we all okay? Axis of symmetry is not enough. I need to know where on this axis of symmetry my vertex sits. And so in order to find that, how do I find the corresponding y value here? How do I, not the y, well, it is the y-intercept this time. But if it wasn't the y, what would I be doing? Plugging in, right? Plugging in, plugging in. Okay, so let's plug it in. Just for the sake of this example, we'll plug it in. F of 0 is going to be 1. No, which means the coordinates of my vertex is what? 0, 1. Sully, you good? Okay. It's okay. It's okay. We don't leave anybody behind. That's right. All right. Everybody else okay? Y'all good? Okay. Now I need my easy point, but I can't use the y-intercept as my easy point because that also happens to be my vertex. So I need an x that I can use. What do you suggest? 5. Why might I not want to use 5? I'm glad you said that because that's good. If I put 5 in here, what's 5 squared? 25 times 5. Plus 1. Holy cow, I'm not counting up to 126. Right? You see why I want to stay close? So give me another good easy point. 1. Maybe 1. I'm going to just say easy. You were trying to give me a good example of why we should do that. That's what you were doing.
How do we know F is 0 equals 1?
Plug it in. I'm sorry, I didn't show that. 5 times 0 squared. 1.
Oh. Wait, where's the line?
So if it helps you do A equals 5, B equals 0, and C equals 1. That's the y value. So that gives me the coordinates of my other point. X is 1. X is what I plugged in. Right. So it's 0 over 2 times 5. It's 0 over 10, which is 0. Anytime you get a 0 in the top, as long as the bottom's not 0, you can just stop and say it equals 0. Everybody else okay? All right, lots of questions about the x equals 1 and how we plug it in and where we go from there and what happens. So whenever I plug 1 in, and let me show all my work here, I'm really sorry. Y'all have to, please stop me like that. I'm coming off of calculus in the morning when y'all come in, so there's a lot, it's a lot. I get confused on where we are, so keep me straight, keep me straight. 1 squared is 1, and 1 times 5 is 5. So this is 5 plus 1, which is 6. Now remember, the whole point of this was that I found the corresponding y value. So this point is 1/6. That is my easy point, right? I've already found my vertex. This is my easy point. So 1/6, 1. Come on. That was a whole lot easier than 126, right? I'm good with that. I have my vertex, I have a point. Now I simply need to do what? My favorite step. Reflect and connect. It even rhymes. What's wrong? Yeah. If I reflect this point, boop, boop. Don't make it a V. Don't make it a sharp V. It's a nice smooth curve here. It's a U. There you go. An elongated U. Do a double check. Did it do everything I thought it was going to do whenever I analyzed that equation to start with? I said it was going to be skinny. That looks like it's pretty skinny, right? More so than a normal one. Y-intercept is 1. It's opening up. I feel pretty confident about that. You're welcome. If you know how to use your calculator to graph this and check, you're welcome to graph it and check. I want to see this work on your homework. Okay. Use tools to help you to check what you're doing, but not to do the work for you. Oh yeah, I did have y'all for enrichment. Yay, y'all be excited. All right. If you want me to do another example, I will work one, and what I'll usually do at this point, whenever I'm done with what I wanted to do, is if you still need some help, I'll do it, and I'll start with your homework that we'll work through a problem together on. If you want me to say yes, okay. If you don't want me to shut up, and then I will, or if you want to work independently on your own while I help a couple people who need another help with another example, we'll do that as well. Y'all have to tell me what y'all need, because I can't read your mind. Hold off on domain and range. I'm going to take a day to do that because I saw the looks on everyone's faces when I said domain and range. Okay, where's your homework? If you go into Canvas, under the heading of today's date, which is August the 2nd, you should see everything you need. In just a moment, I will upload the recording, and that will be under here too. If I ever forget to upload it, please tell me, because sometimes with 3 different classes, I may forget before you leave because it takes a little while to upload to YouTube. But I'll post a link here. So right now, you should see Lesson 1, Graphing in Standard Form. That's the book. Pick it up and just say Miss McGee's room. That's the book pages there that you'll see. The homework here tells you which numbers to do. There's your reference sheet that I gave you. I told you I'm OCD about posting everything. Are you transferring out of my class, Brian? I'm just picking. And then the notes link, of course, that's the Miro board link that we've been working through. I really like it. I find that this is the easiest, especially if you miss class or anything of the sort and you need to go back, all your information is there for you. So, tonight, remember, this is a little convoluted in the way this is because it's book pages. Your homework will come from the lesson, but the numbers assigned and where you'll turn it in is here. So I've got you doing 21 through 31 odd. Okay, I'm not trying to kill you on homework. That's not the point. That's what, 6 problems, 6 graphs to do. We'll do one of them together now. I realize they take a while. I will tell you, if you ever hit the point where you've spent an hour on homework, you have spent too long. Text me and tell me something's happened. I'm spending too long. I'll tell you to stop there. As long as you let me know ahead of time, then I won't penalize you for it being late. As long as you have let me know. I've been working a really long time on this because we need to come together and we need to clear up some space. Chances are, if you've done that, somebody else has done it too. Okay? I didn't do a good job keeping you if it's taking you that long to get through that homework. Yeah. Your Chromebook's dead? I'll post the page up here. I'll keep it up here for you. 21 to 31 odd. Let me come here. So you'll scroll to the very bottom here of this PDF file. Yeah. There we go. Oh no, the answers got cut off on that one. Okay, well I'll have to find them. All right, so let's start with, do you want me to start at 31? Is there a particular one you would like me to do here, or do you want to just start with 21, your first one you have to do? Okay, x squared plus 2x plus 1. Again, if you've got it and don't need any more help, feel free to go ahead and work through. What did I say? I forgot that quick. X squared plus 2x plus 1. Yes. So I've got it where it will accept files. If you have Adobe Scan, it's really easy to work between the two. As I finish this one, remind me and I'll show you how it talks to each other much better. All right. Up or down? Up because it's positive. Is it skinny white or average?
Average.
Average because the leading coefficient or the A value is 1 exactly. Y-intercept. 1. All right, let's find the vertex first by identifying the axis of symmetry or the x part of the vertex. Remember that's opposite B over 2A. B is what here? 2. So this is going to be negative 2 divided by 2 times 1, which is 2. Negative 2 divided by 2 is negative 1. Now, I always tell everybody that everybody always says it looks really easy when you do it, and I sit down to do it, and it's not that easy. That's because I have been doing this for a lot of years. Okay, I know the steps to do, and I know whenever you tell me the wrong step to do, I know how to correct you and tell you. So that's why this is not as easy just to watch somebody do. You have to practice and learn to do it. All right, I have my axis of symmetry. Negative 1. What now? That's exactly right. I need the corresponding y value, and to get that, I'm going to plug into my equation. So I'm going to find f of negative 1, or plug in negative 1 for x is the same. Be very careful if you're using a calculator here, because I'm plugging in a negative value, right? And we all know that when you square a negative number, what happens? It turns positive, but if you take out your calculator and you do negative 1 to the second power, it's going to tell you negative 1. Okay? You have to put these parentheses around it when you're using your calculator because it reads it as that, like that negative x squared we did yesterday. Y'all remember when we did that and we were confused about negative signs? It reads it the same way. All right. Negative 1 squared is 1. 2 times negative 1 is, thank you, which gives me what? 1 minus 2 is negative 1 plus 1 is 0. There's my vertex. Now we need an easy point. That's exactly right. You're exactly right. I'm going to use the Y-intercept here because it's a pretty easy Y-intercept to use, right? Can't get much easier than 1. So I'm going to go ahead and put that on my graph as a Y-intercept of 1. And now what do I do? Reflect and connote. Reflect and connote. Had 1 not worked, I could have picked one that was close to the vertex.